Okay. All right. Check. Check. How's everybody doing today? Nice. Yes. Who started the clap? Yeah. Thank you. Here you go. Here's a badge. Yeah. Hope everybody's having a good day. I think I have to speak into the mic because they're recording it. Normally, I just like to yell at everyone, but I don't think that's going to work out today. I'm not a big fan of microphones. But, anyways, appreciate you guys coming out. Hope you're having a good day. Appreciate B-Sides for having me and allowing me to tell the story of what I did when I wanted to figure out how to fine-tune Llama 3.1. And so that's what I'm going to talk about today. Just real quick about me, my name is Cory Wolff. I'm the Director of Offensive Security at a company called Risk 360, security and compliance consulting firm based in Atlanta. I am not from Atlanta. I am from Scranton and now live in the Poconos. I am a core team member of Red Team Village. So if you've ever submitted a talk or a workshop at Red Team Village, I've seen it. And so I would also recommend that you submit again this year if you are thinking about it or have done it in the past. But myself, along with another gentleman named Wes, we handle the workshops and talks at Red Team Village. I'm also a part-time farmer. I live out in the country. I got bees, I got chickens, all kinds of random stuff going on. But I like to try and balance it all out. Real quick, just about today and some things to know before we really start to get into it. I originally had started to work through machine learning in 2018. I had gotten into, so if you think about machine learning, back then people would get mad at you if you said AI. They'd be like, it's not AI, it's whatever. But back then, you really had to get into the weeds of it. So you had to understand the math behind it. You had to understand things like gradient descent. You had to have basic calculus, which I hate, but I knew the basics enough to start to kind of figure it out. But I had started in 2018, and for various reasons wasn't able to focus on it for quite some time until ChatGPT came out, and I was so mad because I didn't keep up with it. And I was like, I know what they're doing. Why don't I keep up with this? But this was basically, that side project to help me get up to speed with what was going on, right? So there's lots of differences since 2018. Back then, if you wanted to load data, for example, you had to literally load the data set, parse it, clean it, all within your script. Before you even did anything, you'd be 30, 40 lines in, just getting the data together and getting it ready to even start to train it. Nowadays, with things like Hugging Face, you just do load data set and you throw a path to the file, right? So there are lots of things like that had changed since the last time that I had really looked at this. And so that's, for me at least, that was the motivation behind trying to figure this out. I had seen a lot of tutorials, I'd seen a lot of videos and all kinds of stuff, and they made it seem super easy. It's easier, but if you ever see any of these tutorials or videos, you'll see that they leave out a lot of like in-between stuff. And every time I would go to look and I'd try to like catch up with what was going on, I'd get so angry and frustrated because they'd say, just do this, then do this, then do this. And you're like, well, there's probably 4 hours of work in between those steps, right, that you didn't even realize. So that's what this is. As you can see, I'm sure you've already read the code and slides. The code right now is available on the GitHub, so if you want to pull it up and start to look at some of the actual code as I talk through it, you're welcome to do that. In true form for myself, I didn't finish the slides until about an hour ago, so they are not in the GitHub, but they will be by the end of the day. So I mentioned earlier that I am the Director of Offensive Security, and I think that it's important to kind of call out how, the things that I'm going to talk about today is more classified as cyber threat intelligence, right? We're gathering information from threat actors. We're trying to analyze what they're doing. We're trying to understand a little bit better what they're doing. That's threat intelligence. For me, it's important to understand how this relates to offensive security because, like I mentioned, that's what I do on a day-to-day. So I should always be trying to understand and consume threat intelligence. And it's important because that's literally our job. Our job is to emulate threat actors, to do what they're doing, so that we can, of course, test systems, right? So it's important that if there's so for example, in this case, if I'm able to find a way to take threat intelligence, throw it into an LLM somehow, and help me kind of keep up with what's going on in an easier way, well, that's valuable to me. And then lastly, if we're going to test something, we should know how it works, right? So there's whether it's some sort of chat GPT wrapper, or I'm sorry, OpenAI wrapper, or a custom built LLM, us as offensive security people, specifically when it comes to AI red teaming, we need to understand what's going on, right? We can't just, prompt engineering is prompt injection is a big part of it, don't get me wrong, but there's a lot of other moving parts in AI systems. And so we need to understand the whole picture in order to be, really good at what we're actually doing. So that was important to me. It's important to my team as well. But the other thing I wanted to call out as far as attacking LLMs is that, yes, these are relatively new systems, technologies, I'll say, but the systems that serve them are the same things that have been serving web applications and network applications for decades, right? So yeah, it's an LLM, but it's still Vue or React in the front end, right? It's still a Node or Python on the back end with some little tweaks, right? But at the end of the day, that's why supply chain attacks are a big part of what we see in day-to-day. Also, it's fun. So I mentioned that I'm going to talk through some of the pitfalls I encountered. First one is that it's pretty expensive. So for those of us that don't know, if we wanted to train our own model, start from scratch rather, it's extremely expensive, and it takes a lot of data. And so, OpenAI, Google, Anthropic, all the other companies that are generating these types of models are just basically scraping the web, right? And it's basically what they're doing, and that's a lot of data, right? So the more data you have, the better that your model will be. But to just gather that data, I don't know, just even gather that data, like scrape, you're talking about millions of dollars, right? Like a lot of money. And not only that, once you have that data, you can't just take that data and throw it into a training model, right? You got to clean it. You got to normalize it. There's different formats. There's different, prompt templates. There's all kinds of different things that go into actually training an LLM. So just because you have the data doesn't mean that you can actually use it, right? You have to take a lot of time to normalize it and get it to where you want it to be. That's basically data science, right? When we see people talking about being a data scientist. And then, of course, you need to train it, which I think we're all familiar with NVIDIA being a 400 billion quadrillion company nowadays. That costs a lot of money. So this is why we use pre-trained models, because companies like Meta, I won't say OpenAI because they are closed source models, but companies like Meta, BERT, Mistral has open source models. They do all that heavy lifting, and so when we get those models, we can then do things like fine tuning on them, right? So even if we were to start with, creating our own model, it'd be extremely expensive. So we use pre-trained models and then fine tune them. You can do this a couple of ways, but even when you want to do it locally, it's still an investment. And so just for your own understanding of what I was working with during this is my basic setup. I had a 4070, decent amount of RAM, which it will max out. So I had 64, and I wish I had more at the time. But it will max out because a lot of times you're doing things like loading the whole model into memory, or you're doing a lot of computations. So for example, as I get a little bit further down, I had to generate some question and answer pairs for training data. And this is basically just a looping through lines and making certain calls to another LLM. And that alone was like 18 gigs of RAM, just doing that, right? right? So I'm able to do this with the setup that I have, and everything went well. But that's still an investment because it's a decent machine. At a high level, when we're talking about fine tuning, it really comes down to three high level areas. You gather the data, you create the training data, and then you fine tune. So in this case, I gathered the data from Telegram's API, and basically have a list of Telegram channels that I wanted to grab messages from, use the API to do so, store them, and then move down the process. But there's lots of different ways you can do this. So you can grab public data sets from Hugging Face, for example. And if you're using the data sets library from Hugging Face, you can literally just put in a data set name, and the Python package will literally just pull it down for you. By the way, if you're interested, if you look on the GitHub, there is a link to the data set that I gathered for this training, which is available on Hugging Face. So if you go to the GitHub, you can see that. But it starts with gathering the data. So here's just some sample data of some of the messages that we were looking at in various channels. So this, by the way, is just all breach data, just like usernames, passwords, that kind of stuff. But just to kind of give you an idea of the things that we're looking at here, these are just some of the messages. They're exactly what you would think they would be. They're idiots. So basically we had all these and we needed to gather them. So using the Telegram API, long story short, it's kind of weird, really weird, just the way they do it. For those of you that aren't familiar, Telegram was built by, I can't remember his name right now, of course, because I'm in front of people, but the Telegram founder is the same guy who founded VK in Russia, which is basically their Facebook, if you didn't know that. Got kicked out of Russia, got in some trouble because he wouldn't give Russian authorities data on its users. Eventually, Russia got data on the VK users, but their founder left, became, I think, a citizen of France, and was recently arrested, if you follow the news, sometime in the last 3 months. But he prides himself on being a hands-on keyboard coder. So him and I think his brother basically built this whole API, and you can tell that he's not a professional. It's annoying. It's real annoying. So I mean, I'm not. I wouldn't say I'm an enterprise software engineer, but you could tell it was weird. So it took a little while just to understand. A lot of times, like when you go to API docs, like it's just there, and you can look at all the endpoints, and it'll tell you what the endpoint accepts. It'll tell you what the endpoint is going to return, right? The Telegram API isn't like that. It took a little bit longer than I expected to really understand how the API works. And then there's limited packages, at least in Python, there's limited packages to actually interact with the API. Sometimes I'll default to just using like requests and literally just like put it together myself if I have to. I don't know why. I can't tell you why, but that just wouldn't work when I try to call the Telegram API. It was a lot. And I've worked with lots of different APIs. Auth is based on the phone number. It's kind of OAuth-esque, but again, it's kind of weird. If you do any of this, I hope it goes without saying, use a burner number. Do not use your own. But everything is based off your phone number. Like a lot of places, a lot of accounts you get is based off your email. Of course, in Telegram, it's a little bit different. But needless to say, it's kind of weird. But eventually I figured it out. And here's just a code snippet of what it looked like looping through some messages. So, basically I had a list of Telegram channels. I was looping through those channels. I was grabbing all the messages, and then this is just that code block that shows the portion of that. Just to kind of reiterate it being weird, if you see one of my comments there, it says, seems silly, but we call history.message, it returns everything. So like another example of working with their API is if you say, give me all the messages, it'll give you all those messages, but some of them might be empty. So you had to kind of do like just little silly things like that just to deal with the Telegram API. A lot of times, like stuff like this would just take me like an hour or two to figure out. This took me forever because of just stupid stuff like that. I'd have to actually like print out the whole thing and look and investigate, and there's no documentation. But this was probably one of the tougher parts of the whole process, was actually getting the data. The other thing is, like, a lot of times when you read or you see tutorials, it's like, yeah, just use this data set from Hugging Face, but the data set is not related to anything that you want to do with the LLM. So it was really important to me that we figured out a way to get fresh data and get relevant data. So of course I continued to kind of fight through it and figure it out. Just some other call outs as to what's going on with the code here. So in that line that I'm pointing out, this was to remove, basically I just wanted to make sure, so when you get it returned back, there's all kinds of weird stuff in that response. So one easy way to clean it up is to convert it to ASCII and then just decode it, because it'll basically just remove everything that's not ASCII. So that's what I'm doing there. I'm just kind of cleaning up the response. Next one is I'm adding context. So these messages are going to be fed into training data. So what I wanted to do was just kind of give a little bit of context when I start to create that training data. So I formatted the message in the way that you see there. And then at this point, I don't remember why I did base 64. I think I was super frustrated at some kind of formatting or encoding thing, and I just base 64'd it and just dumped it in a file. So ran through all these and ended up with 18,000 messages from 5 different Telegram channels. So here's just a quick output of my script running. But again, I mean, it seems like it took a little bit longer, much longer than I expected it to, quite honestly, just because of the way Telegram's structured and their data types and all this kind of stuff. So I had the data. Well, yeah, I had the data. And then I needed to move on to create training data. So I needed to formulate it, get it ready for the LLM. Lots of different ways you can do this. But ultimately, I used another LLM to basically create question and answer pairs, which I'll get into in a second. But I had the data, and it was time to create the training data for fine tuning. I mentioned this earlier, but every single thing that I saw, it's not going to take 15 minutes. So that's kind of the second lesson I learned here, is it's not going to be as easy as I thought it would be. There's lots of these videos that are 5 minutes, 10 minutes, 15 minutes. And when you watch the video, it's like, oh, well, that makes sense. And they link to some notebook or something somewhere. You're like, oh, I could just copy and paste this. I'm good, right? No, it's not. It's definitely not going to do that. It's definitely going to take longer. So it's definitely going to take a lot longer. So I would suggest that you keep it simple. So I showed you my system setup before. The reason that I went with WSL is because managing NVIDIA drivers and CUDA drivers on Ubuntu, I don't know, maybe I just have no idea, but for me, it's always a nightmare. And you need very specific CUDA versions depending on what you're doing. And so for me, I basically said, all right, it's 10 times easier on Windows. I'm just going to use Windows. And then the good thing about that is if you install the Windows driver and it passes through to WSL. So you don't even have to worry about it. I can still use Ubuntu, I can still use Linux like I like to, but I don't have to worry about these drivers, and I can actually figure out what this stupid Telegram API is doing. Use Conda, I don't know why. I'm more of a env or a pip env kind of guy when it comes to Python, but AI engineers seem to love Conda. I fought it at first, and it was a terrible idea. So if you end up doing this, I highly recommend that you just, if you've never used Conda before, it's pretty easy. It's a Python virtual environment, but I would highly recommend that you do that. And of course, be ready to read. So we talked about gathering the data. Now we're working through getting it ready for training. I mentioned earlier that there's different formats that these models take, and depending on the model, it takes, of course, different formats. Llama 3.1 uses alpaca format, which basically just breaks down into a JSON object, which is an instruction, an input, and an output. And there you can see a screenshot of some of the actual data that I gathered in Hugging Face. But I had to take these basically, just messages and start to put them into training data. And, one of the common ways to do this is to actually create question and answer pairs. So if you just have an answer, you just have raw text, you can't just feed that in and fine tune the model. You need to come up with an instruction, right? And so one way to do that is to generate Q&A pairs. But like I showed before, there's 18,000 of them. There's no way that I'll be able to just manually answer these, right? And so an option here is to use Llama. So has anybody used Llama before? Yeah, right. So Llama is just an easy way to load a model locally and basically query it, right? So it allows you to, it's pretty easy to set up and install. And so like if you wanted to just run Llama 3.1 locally, you literally just install Llama. You do Llama pull, I forget what it is, but Llama 3.1, it'll download the model for you. It'll get it ready for inference. It'll spin it up, and you can actually just use that model locally. But the other thing is that it has an API. So what you can do is, if you can find a model that you like or that gets you the results that you want, you can have Llama run it and then use the API to generate those question and answer pairs. There's lots of different file formats as far as outputs, but something that I wanted to note is that Llama requires GGUF, GPT Generated Unified Format. Remember that for later, because that'll make your life a lot easier. It's basically a single file format that just makes things easier to move the model around. A lot of times when you're working with LLM models, there's like what they call shards. So there's like, I don't know, if it's a 20 gig model, there'll be 5 gig shards, right? And it's a bunch of pieces. Most of the time you'll see like there's a format called safe tensors. And most of the time when you see safe tensors, it's like that. It's real annoying. There's JSON.config, there's all this different stuff. But GGUF is a single file, and basically Llama works with those. Another thing to keep in mind is that Llama uses Llama CPP under the hood, CPP for C++. It's a C++ written, I don't know how you explain it, but it basically performs various methods on models. So like if you need to transfer from one quantization method to another, Llama CPP can do that for you. But anyways, what I need to do is generate Q&A pairs. So I tried a number of different ways to do this. I said, ChatGPT, here's my data, give me some Q&A pairs. It didn't like that very much. It wouldn't do it, because of content. And then you can also get uncensored models. So a popular one is Dolphin Mixtral. So there's Anthropic has something called Mistral with an S, which is a mixture of experts model. But basically, it's a pretty good model. And what happened is that they created an uncensored version of that Mistral model, and that's called Mixtral. Try another one called Neuromade. That was hot garbage. I don't know why it didn't work, but it was just spitting all kinds of nonsense out. And so I ended up using a model called NeuroChat. So what I basically did was I just went into Llama, pull NeuroChat, and then served it, and basically scripted a way to loop through all my stuff and get Q&A pairs. Here's some examples of when I was trying to get ChatGPT to generate these a subset of the data. So I gave it 200 and said, hey, I gave it 200 and said, generate some questions for these answers. Basically wouldn't do it. And then I'm not sure if you can really tell, but it's spitting out. So like that Spark thing, you see Spark, like that's a random piece of a message. So it was just like spitting out like random data, and it just wasn't working out. I moved on and started to use NeuroChat. And so here's an example of doing that. So again, I mentioned earlier, I spun up Llama, You use NeuroChat and then script it a way to loop through all those base 64 encoded messages that I gathered and generate questions for each and every one of them, which of course ended up with about 18,000 questions. This was actually fairly quick. I was very surprised at how quick this was. And the questions were pretty good. There's definitely room for improvement there, but they were good enough for my particular purposes. And so at this point, that's kind of where we were at. Oh, and then dumped them to JSON-L file. So for those of you that don't know, I don't know why, but AI engineers and data scientists love to use JSON-L, which is just JSON lines. It's a JSON object per line. So every new line is one JSON object. I don't know how that's different from just parsing it, but this is a JSON-L format with all those questions and messages, aka answers. So we're at the point where we gather data, we created the training data, and now we can fine tune our model. I mentioned earlier that in the past it was very kind of manual thing. So before there were things like Hugging Face or Unsloth, which we'll talk about in a second, you basically had to use something like PyTorch and NumPy to go through and basically do all your calculations. It was a pain. But of course now we have advanced our tooling, right? But kind of the last big lesson that I learned through this was that just gathering that data is half the battle. So fine-tuning a pre-existing model, there's lots of different things that can go into it. There's there's a decent amount of ways that you can actually do it. Ultimately, I decided on using Unsloth, which basically uses different ways and methods to cut down on the amount of RAM that you need, just the amount of general computing resources that you need in order to fine-tune a model. Unsloth is specific to fine-tuning models. That's what they do. Written by a guy, Daniel, I can't remember his last name, but it's basically one guy, which creates headaches for you down the road, because it's just one guy maintaining this big project. If some breaks in it, you're kind of reliant on that guy to go fix it, right? And in the meantime, you're waiting or you're trying to figure something else out, and you end up going down another rabbit hole instead of just trying to do what you were trying to do. So that last big lesson for me was that just gathering the data and getting it ready for training was just half the battle. Trying to work through actually fine-tuning this was going to be a challenge. There's a couple of different ways that you can fine-tune models. One of them is called LoRA, or low rank adaptation. It's just another. There's QLoRA, there's LoRA, there's a bunch of them. But it's one way to fine-tune models. Now you could theoretically take a model and just continue training on it, right? Theoretically, you could do that, but you would basically have to hit the entirety of that model, right? So you would have to go through and look at, every single parameter in the LLM model, and that's a huge model when you're talking about Llama 3.1 or any of these other bigger models. But it really adds an additional layer onto the model. So you're really just, when you're doing LoRA fine-tuning, you're really just focused on adding an additional layer on top of all the other layers that happen during training, right? And adding our data on top. So when we do that, though, it's called LoRA adaptation, right? So when you do this, the adapters are saved separately, right? So it's not like if you do it and you fine tune it and you just save it, at the end of the day, you just have that additional layer, right? The additional adapters. It's not the whole model. So that's just something to keep in mind, that if you fine tune it, you're just going to end up with adapters, and you're going to need to do some conversion, some other stuff to add your LoRa adapters onto whatever model it is that you're trying to fine tune. So when it comes to fine tuning, if you can kind of think of it, at least I did, in 3 high level areas. You do the fine tuning. We want to get it into GGUF because that just makes it easier to put it into Llama, to put it into LM Studio, basically to actually use it. GGUF makes things a lot easier. So that was a big part of it. But for me, it was fine tune it, get that GGUF file, which you'd think would just be like a one-liner. It's not. Get that GGUF file and then import it into Llama. And yes, I know that's a sheep, not a llama. So, like I mentioned, I decided. Sorry, I'm moving fast. There's just like so much stuff, and I'm doing all right. But if you have any questions too, please just like interrupt me. But like I mentioned, I decided on Unsloth. They do have a lot of really good examples. Like I'd mentioned probably 1,000 times already, I thought I could just copy and paste and get on with my day. That did not happen. But basically for my purposes, and I guess maybe for your purposes as well, all you really need to know is that it does some fancy stuff to allow quicker loading of these models and then actually fine tune them. So if we wanted to actually go down the process of training the model, first we have to load the model. So in this case, Unsloth has optimized models of various other models. So what I'm doing there is I'm calling Llama 3.1 the Unsloth version of Llama 3.1, which is optimized. That's where you need to start, right? This is what we're fine tuning. We're fine tuning Llama 3.1. Right. And then on that second part there is where we start to actually load in the model and start to set some hyperparameters related to fine tuning. That also is through Unsloth. So Unsloth fast language model is an Unsloth optimized version of Llama 3.1 pretty much. So the first place we want to start, of course, we're going to fine tune a model. We need to load it, right? Here we go. So now we need to actually load our data set. So these are all the Telegram messages. And like I mentioned before, in the past you had to like basically rip everything out, you had to basically load everything yourself, clean everything up on your own. Now you can just use load data set from Hugging Face. So Hugging Face has a bunch of Python libraries that make things a lot easier for you. And so that's where you start. So we load the model, now we load the data, and now we need to set our trainer. So Hugging Face has the SFFT trainer, which is the supervised fine tuning trainer. All the stuff that goes along with that are what are referred to as hyperparameters. So these are basically all the variables when it comes to fine tuning and training, but when it comes to fine tuning. And these are the primary variables that I was working with to fine tune and like get the LLM to do what I wanted it to do, right? Because if these parameters are off or they're not where we want them to be, it can really, your model just doesn't do anything. The output isn't any good. But these are what you need to kind of work with. Some of the big ones are epochs. So epochs are how many times that it'll actually run through your data set, right? Because if you only have one epoch, that means it's just only going to go through the data set once. That's an important one to keep note of. The other one is steps. So when we're training with Unsloth, steps is how many actual steps it'll take through the data. So you can set these parameters differently. It'll depend on how much data is ingested, how much training stuff happens. There's just talking through all these things is a talk on its own. So I'm not going to go down that road. But those are what are referred to hyperparameters. And then you train. So in this case, we're fine tuning, but you train it. And that train is Hugging Face. So when I first saw this, I couldn't believe my eyes, because to train back when I was first starting to look at this kind of stuff, there was all kinds of different things. You had to loop through stuff. You had to do like you had to bring in NumPy and do like crazy calculus on things. You had to calculate the loss yourself. Like you had to do all this stuff. And I saw this and my mind was blown that like you can do all this just in one line, right? You just do trainer.train. But that's what is actually fine tuning the model and using all those hyperparameters and looping through, right? So if we think about how machine learning operates in general, if you were to start with a new data set, if you were to create a new model, you would start with your data set. You do some calculus on it, but basically you can loop through all your data. So you have a big data set, right? And you say, okay, here's the answers to 30% of our data set. Give me the answers for the rest of the data set. And you can calculate when the model was right and when the model was wrong, right? And that's your loss. And so what you can do is you can basically just continue to loop through, and you want to optimize on that loss. And so you just keep looping through. Here's 20%, give me 80%, blah, 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 and you calculate the loss. And so that's what that trainer.train is doing, is it's looping through, it's saying, here's X amount of right, give me the answer for X, and that calculates the loss. It changes some of the parameters. It does it again, right? And it's doing all this pretty much on its own. So it's I mean, this whole file is probably 80 lines or something. It's really easy. Well, shouldn't say easy. Shouldn't say that. So going back to kind of my high level three-part process of fine tuning, it was train the data, get a GGUF file, and then use it in Llama so I can actually ask it questions. This is a documentation, excuse me. This is a documentation from Unsloth, and as you can see, it's really easy. It's just a one-liner that creates a GGUF file, but no, it doesn't work. So everything, I cannot tell you how long I spent just trying to figure out how to get to a GGUF file, because everything I saw said, yeah, just do this one-liner, save pre-trained GGUF, right? And it wouldn't work. I mentioned earlier that Unsloth is developed by basically one guy, and what happens is that when you are using Unsloth to fine tune, right, it needs to use Llama CPP, which I mentioned earlier. So what it does is it looks for Llama CCP in a folder. So if your project folder is teletrain, in my example, it's looking for a Llama CPP folder in my teletrain folder, which why would I ever put it there? But regardless, if it's not there, it errors out. So I figured a workaround to that. I go, okay, they said, yeah, you need to basically go back a couple versions. You have to do some GitHub stuff to get like an old commit, build it, and then the files will be where you need them to be. I did that. It still didn't work because something was broken in Unsloth. And it was literally just looking for a specific file that didn't exist anymore in Llama CPP. And so this took forever to kind of just get this to where I needed it, because like I said, I was like, oh great, here's a one-liner, it's just gonna dump out the file that I need. Didn't go that way. Spent a lot of time Googling and that kind of thing. Finally worked through it and got it done and figured it out. But that's the thing with a lot of these tools, like AI and ML are moving so fast that, technology has always been fast, but this is at like hyper speed, right? Because the tooling changes like by the hour, like literally like by the hour. There's some new update that breaks everything, and you have to kind of start over again, and it doesn't work with this other tool, and it's just so fast. The advancements in AI and ML just in the last year or two have been, exponential. I mean, it's really insane. I just can't explain it. But the point is that these two different tool sets were moving too fast, that they couldn't even keep up with each other, and there were breaking changes here, breaking changes there, And so when you go and you want to fine tune something, it turns into quite a headache. In this case, that's what happened to me. I ultimately figured out how to do this, but we can. So I mentioned the GGUF format. I've talked about Llama CPP. That file format was created by the developer of Llama CPP, right? Which is why they work so well together. And so that's why I wanted it. Old Llama under the hood is using Llama CPP, right? So that's why I wanted this file format. And so one way that we could do that, instead of just using that unsloth one-liner, is to create what's called a merged 16-bit file, which I mentioned earlier. LoRa, there's the adapters, and then there's the model. They're separate, but you can merge them together into 16-bit quantization and basically have what I need, right? And that's what I did. I ended up saving it in a merged format, yeah, there you can see it. So this is unsloth. You can see my comments in the one that I actually ended up going with. But that's what I did. I ended up saving it as a 16-bit merged model file. And now we can use Llama CPP to convert it. So Llama CPP has a whole bunch of Python utilities. One of them is convert HF Hugging Face to GGUF. You basically give it an input of the folder where your file lives, where your model files live, and it spits out a GGUF file. So at this point, I was probably 60 days into a project I thought was going to take me a weekend. And I was very happy to get to this point because that was like, for me, that was the holy grail. I was like, just get this one file. If I can get this one file, I can actually test it. I can use it in different tools. Like this is what I was working towards. And no joke, it was something that I was like, oh yeah, I could do this in a weekend. Till like 2 months later, I finally had it figured out. So I know it's just a screenshot, and you weren't there, but for me, this is a huge win right here. I can't explain to you how big of a win that was. So anyways, so we have the file format we want. When we want to run these types of file formats in Ollama on our own, you create what's called a model file, which is specific to Ollama. It's basically just a config file for a model you want to load. You tell Ollama to create it, and pass it that model file. Ollama creates it, and then you can actually run it, right? So that's what that last line, is me actually running it. So this is when I was able to start to actually test it out. So at this point, I had it. I got it done. I got something at least that I could test. But the results were not great. They were not great at all. And they gave all kinds of random stuff. Sometimes, so star fraud, star chat is a chat. So you guys familiar with the Snowflake breach, right? The guys that the primary threat actors in that were in star chat. It's basically just, I don't know if you're familiar with that whole crew. It's like a bunch of like 18 to 25-year-olds just doing work. And they're like, one of that star chat is one of those channels where they basically make fun of each other and, post breaches and that kind of stuff. But it's definitely not, where does it say it? Yeah, so like here, for example, it says breach discussion, right? Breach discussion isn't a channel. There's a channel called Breach Data 1, right? So that's not even close to like what it is. And some of the stuff on the top, it just wasn't, like it should have gave clearer answers. So I did some fine tuning of those hyperparameters. Basically, I gave it more epochs so that it got to go through the data more and it started to get a little bit better. You can change things like learning rate, which basically is how much data it ingests per learning cycle. So I basically messed around with some of those and got those to where I wanted them to be. I know this is a big old block of text. I couldn't figure out a better way to show this to you, but this is a better response. So if we look at, I'm basically asking it, what's the main feature of the service offered by Gorilla Panel, Gorilla Mail Spoofer, and Gorilla Callbot, which are 3 services advertised in one of the Telegram channels. And it got a little descriptive, a little too descriptive, but it actually, the information it gave me was correct. So, which to me, I was like, all right, great. I just need to figure out how to tell it to shut up and tell me what I want it to tell me instead of going on a long thing. Like, this is basically, that whole thing is its answer. So I was able to really kind of get it to at least give me the right information, and the information that because hallucinations, they call them hallucinations, but models will sometimes just make stuff up like it did here. Like, it's just kind of making stuff up in these responses. It's because it's, it has underlying Llama 3.1 data plus the data that I throw on top. It's just making stuff up. At least in this case, it was factual, right? What they're saying, and I went and looked and checked. It was actually what it was supposed to be, but it was just a little too long. And there's certain things that you can change, like, let me see if I'm probably going to just make a mess of this, but where is it? There's certain things that you can change where if you see temperature, for example, this is when I was generating those QA pairs and calling out to Llama via API. Like, temperature is something you can change that describes how descriptive it is. Top K, I have no idea what that is, but what it does, it determines how responsive and how descriptive the model is, right? So basically the point is that you can fine tune and tweak some of these things without having to retrain the model. Like, I could fine tune this stuff directly through Llama API or whatever other application you're using, right? So it had given me the response. It was factual, and to me, I considered that a win. So since this screenshot, I've done a little bit more. It's gotten a little bit more precise. So the idea is that, at least for me, is that if I could continually, kind of update this model, I can ask it generic questions like, what's going on in, what's going on in threat actor Telegram messages, and it should be able to give me a summarized list of like trending, like trending topics, that kind of stuff. Or if I have a question like, hey, what's Gorilla Mail Spoofer? I can go in there and it's going to tell me what it is and the user that makes it and where to find it and all that kind of stuff. So that's the end goal. I'm pretty close. Still needs some more tweaking, probably a little bit more data. The sample size that I used to fine tune this was 18,000 lines, which is relatively small. A lot of data sets that you get are like 100,000 lines of various information. Yeah, so for me, next steps, refine hyperparameters like the things I described. Clean up the data. I could probably figure out a way to do some better question and answer pairs so that the model is a little bit more focused and just accumulates more data. So yeah, I think that's it. I feel like I kind of just like talked super fast, but there was just a lot to kind of talk through. Give me, by the end of the day, we'll have these slides up there. Also want to say thank you to a gentleman, Matthew Nickerson, who used to be on my team. I used to work at a company called Layer 8, they're based in Malvern, where I was the practice manager of OffSec there. Matthew was part of my team there, and he's been super helpful with all this threat intel stuff. So much appreciated to him. Also, I got a whole bunch of Red Team Village swag, so if you want some patches, stickers, whatever, please come up and get one. And I appreciate you not all falling asleep. Thank you.